thought we would just start by talking a little bit about how you first heard of David Stove.
I was a student of David Stove in philosophy at Sydney University in the early 1970s. At that stage, he was just getting into his stride, I think, as a philosopher and explaining the nature of logical probability and its importance for philosophy of science. So I studied philosophy of science with him in the first year. And then in the third year, a very small group of us studied his book, that was just appearing at that time, Probability and Hume's Inductive Skepticism.
Did he have a reputation at the university that made you want to take his class, or what led you to him?
Well, he had a reputation, but more a political reputation, that he, of course, as you know, the early 1970s were about the high point of activism, left-wing activism, and he was one of the most conservative people in the university. He had a reputation for that. I wouldn't say exactly he had a reputation in philosophy. He was not well known at that time, and quite rightly, because he'd only just getting into his stride at that time. We certainly didn't realise that he was going to be such an important figure as he became later.
And his dad was a school teacher.
That's right.
And that must have had some influence on him in terms of curiosity and learning and certainly debate. I mean, he's such an incredible argumentative.
Yes, that's right. I didn't know much about his family. I think he was something of a one-off even in his family. He had a brother who was not an intellectual at all. And I wouldn't say his father was a school teacher, so he was well educated. But I think he really only developed when he came to Sydney University and studied with the important philosopher John Anderson in the late 1940s.
And what was it about Anderson that you feel like made it such an impression on him?
Anderson was a Scottish philosopher who made a very impression on everyone. Yes, he completely dominated Sydney University arts faculty, and he had a personality that also dominated people and caused people to become disciples of him. So some of his disciples, like David Stove and his colleague David Armstrong, later a very distinguished philosopher, reacted against Anderson, and that's what made them. And I remember David Stove wrote something about the influence of Anderson. He said, "You can't believe the force of intellect, the force of his argument." What he learned from Anderson was that if you were very careful with argument, the force of the argument itself just forced people to agree with it or to think they couldn't see what was wrong with it, irrespective of any force of personality. So I think David Stove and David Armstrong became masters of logical argument.
And Anderson had some critique of Stove, right, where he says he didn't think he was very good at logic.
That's right. It's typical of Anderson to disparage his disciples, especially those who disagreed with him.
Is that his way of encouraging them, maybe?
No, it was just him.
You know, the idea of logic in an argument is something that comes across so clearly in Stove's writing, right?
Yes.
And the way he deconstructs language in order to pull apart arguments.
Yes.
Is that something that he ever taught to you all as students, or how would he approach that?
He did, I suppose, more implicitly. I mean, he just concentrated on his argument. So what the course was about was largely logical probability and the errors in David Hume's critique of the rationality of induction. So he didn't talk in a sort of meta-discourse about you just did the arguments themselves and followed his deconstruction of Hume's argument. He did talk explicitly about the rationality of the relation of evidence to conclusion. So really that's his big take-home message, really got from Keynes, the economist. Stove is an admirer of Keynes's treatise on probability of about 1920, which introduced most clearly the idea that the relation between evidence and conclusion in an argument, scientific argument, legal argument or whatever, is a matter of absolute logic, that the degree to which the evidence in law or in science supports a conclusion, like that the defendant is guilty or that the Big Bang hypothesis is true, that relation between evidence and conclusion is a matter of absolute logic, and there's right and wrong about it. Either it's strong or it's almost certain or it's weak or whatever. And if people disagree about that, one of them are right and one of them are wrong.
So how do you apply that same sort of methodology to his challenge to Hume's?
He said that the trouble with Hume was that he didn't recognise that relation. He said that after deconstructing Hume's argument, so Hume argues that induction, the inference from past to the future or from sample to population or generally from the observed to the unobserved, which goes beyond what the evidence you're given, Hume says that can't be rational. There's just no reason to think that because the sample is one way that the population it's taken from is approximately the same way, because there can't be a connection from observed to the unobserved. There's no kind of glue that cements in here to out there. And so in effect Hume said, though he didn't say it explicitly, he says it's deductivism, meaning that the only logic is deductive logic as opposed to probabilistic logic. So if it were true that the only logic was deductive logic which follows from certainty, then definitely there couldn't be a rational argument from past to future or from observed to unobserved. But Stove says Hume's error is not recognising that there is logical probability, that there can be uncertain evidence, that is a relation that gives you good reason to believe on the evidence some conclusion, even though it's not certain reason. So Stove says that Keynes was right, that there is this relation and that you can understand it intuitively. You understand that, and in fact the jury in a case in law, it's exactly their job to understand whether the relation between the evidence presented in court and the hypothesis that the defendant is guilty, is it strong or isn't it strong? And they're right or wrong about that. You should therefore concentrate on understanding how to do that.
And was there any part with Hume's idea of sort of experience being a part of the problem with induction, right? Or a part of his skepticism towards it? And Stove seems to counter that by saying, well, logic falls right into that bucket. So that's the error in your argument.
Yes, Hume says that the only arguments are all you have to offer is experience or deductive logic, deductive meaning as in mathematics with things follow from certainty. And if that were so, you couldn't get beyond experience. You can't infer anything from experience. But yes, Stove and Keynes say that there is this logical relation, and that logical relation is not itself a matter of science, it's a matter of absolute certainty and that you understand by intuition in effect. So the first thing, the most basic principle of logical probability is that theories are confirmed by their consequences. So if a theory makes some predictions and those predictions turned out to be true, well, the theory is more probable than it was beforehand. So that's not a principle that you have to discover from experience itself. It's what allows you to make any conclusions from experience. You must have that logical principle first before you can get anywhere.
And so it's not a yes or a no, a 1 or a 0.
That's right. It's exactly. It's any degree from 0 to 1. So in law, in civil law, you say if there's a dispute about the ownership of property, all the property goes to the party that has the better case on the balance of probabilities, meaning 50%. Now that is, according to the theory of logical probability, an absolute standard, and that people, a jury or a judge, are supposed to evaluate on the basis of evidence. And it's not something that, it's a matter of intuitive logic rather than a matter of science that itself you can discover from experience.
And so we go from Hume to Popper with sort of Stove's detest of people who deny induction.
Yes.
How did that transition happen, or development or evolution in his thinking, where he decided that he was going to start taking on what he called the irrationalists?
We're talking about the mid-20th century, when the two dominating figures in philosophy of science were Karl Popper, author of the Logic of Scientific Discovery, and Thomas Kuhn, author of Structure of Scientific Revolutions of 1962. So those books were immediately immensely popular. So Stove is writing only a decade or so after The Structure of Scientific Revolutions, which came to be the most cited book of the 20th century in the humanities in any topic at all. It's just extraordinary. And it was cited mostly by humanities people who wanted to talk about science, as opposed to scientists themselves who regarded it as a nice story, but didn't tell them much about science. So because of the domination of those two figures, Stove felt that to rescue philosophy of science, to rescue the story of the rationality of science, he had to explain what was wrong with them. And he says his basic diagnosis is that they're deductivist. And so Kuhn, for example, replaced the idea that evidence really makes a theory more probable with a kind of sociological story about paradigm shifts, as if a generation of scientists decides that they didn't like the previous generation of scientists said and felt they had anomalies in it. So they come up with a new theory. But the new theory is not, according to Kuhn, essentially better supported by evidence from the old one. It's just resolves some anomalies, and it will be overthrown in due course as well.
And he even goes so far as to say, like, nothing is learned.
Both of them say some things that are internally contradictory, but in effect, they're saying that science doesn't advance. So the basic idea of Karl Popper was that theories had to be falsifiable, but they couldn't be confirmed. So Popper says you should submit theories to difficult tests, rigorous tests, which is perfectly true. But then he said that if they survive the rigorous tests, you're not any further advanced. If they don't survive, you know the theory is false. But if they do survive, he doesn't think they're more probable than they were before. They're just not refuted yet. Now that is, if you think that, then of course you can't make any true advances in science.
It's going backwards.
It's impossible to go forwards. Mm-hmm. Yeah. So Stove very rather wittily says that it's something like Aesop's fable of the fox and the grapes. So Popper is saying that you can't find the truth in science, and he says that the parallel will be complete if the fox not only said that the grapes were sour, but then went on to write many long books on the progress of viticulture. So that refers to Popper's talking about the logic of scientific discovery, even though he's saying that there's no logic of scientific discovery. That is, you can't logically make an advance in science.
Well, it's a circular
yeah,
logic, right? Why don't we get into some of the logical, positive, sort of ways that Stove put these ideas out there and how controversial they kind of were at that time. I mean, we're starting to look at this now as a part of the Broken Science Initiative, and it feels revolutionary, but he was doing this long before and got a lot of flack for it. I mean, really was attacked in a lot of ways for his ideas.
Yes, so he did write a very polemical book in the early 1980s called Popper and After Four Modern Irrationalists. And the four are Popper, Kuhn, Lakatos and Feyerabend. Lakatos taught mostly about mathematics, and Feyerabend just said everything was irrational. So Feyerabend certainly thought of himself as an irrationalist, but the others, no, they were thought to be the people who truly discovered what science was doing. And they didn't think of themselves as irrationalists or undermining the rationality of science. So Stove was rather revolutionary in that way. And because his book was, extremely polemical, then that produced quite a lot of flack. So in the time since then, things have changed in the philosophy of science. So Popper and Kuhn are a little bit on the back burner. And in some circles, ideas like Stove's are, they're not exactly, they're not dominant, but they're sort of recognised. For example, in this theory of statistics, there's objective Bayesianism, which is in effect the same idea that you can have an objective conclusions from statistical evidence. But it's been a long road to get anywhere, and it's certainly it's not the majority view. And in fact, things got worse, as Stove said, in the late 1980s. So the next wave in philosophy of science was sociological theories that completely avoided talk about logic of science and said it's all about scientific theories of belief because of patronage or for political reasons.
Is that when the department split off and they had like the traditional modern philosophy department? I don't know enough about that. I'd love to hear more.
I recommend my book, Corrupting the Youth, A History of Philosophy in Australia, for what happened in the 70s. No, it was a little earlier, in fact, at about 1973 and 4, because of the political trouble, the political troubles that were kind of diffused across the university became extremely concentrated in the philosophy department. Even there was only 7 or 8 people in it. It split into 2, and that was a relief to the more conservative people like David Stove and David Armstrong, so they could get on with doing their serious work in philosophy of science and so on. Whereas the other department, the Marxist department, had to spend their time attending departmental meetings all the time to make sure they weren't stabbed in the back by the other sub-factions.
I'm sure they didn't call themselves the Marxist department, though. What did they call themselves?
They got away with calling themselves Department of General Philosophy, as if they were the kind of natural people to enrol with. But part of the reason for setting them up was to institute courses on Marxism, Leninism. So they were certainly explicitly Marxist, yes.
And was there enough of an awareness, like with the student body, about what these different sort of schools within the school were doing?
As a student body always is, we were completely clueless about anything and just listening to whatever the student newspaper said. So I was unusually conservative for a student, and in that case, I guess that helped me get along well with David Stove. But we still had basically no idea what was going on.
And you've written a little bit about how some of his conservatism may have been fueled by some angst or anxiety, depression, the tendency to think all these things are, the worst outcome is the most likely.
Yes, that's right. I do have to say Stove did have a little bit of a depressive temperament at the best of times. So, for example, when at the fall of the Berlin Wall, fall of the Soviet Empire, he and other right-wing people, of course, were very happy with that. But he did take a pessimistic view, and he said, Eastern Europe, it ought to collapse into chaos. So what happened in Yugoslavia, he really thought was going to happen right across there. And he was a little surprised that things worked out so well. And
was that commonplace for him to have sort of an emotional attachment to outcomes like that?
I think so, yes, yeah.
Because, one of the things that comes across for me in reading his work is his sense of humor.
Yes.
And there is a sardonic quality to it.
That's right. It had a sense of humor with a sardonic and polemical edge to it.
Is that I hate to say nasty, but is that a little bit of his zing?
Zing, yes.
Is that, right. and that was present all the time, not just in his writing?
No, that's right. That was definitely very much, inborn, or certainly true of him well before my time.
And were you ever the brunt of any of that?
It was not done in a personal kind of way. It was, he thought his jokes were like the one about Aesop and the grapes. They were about the ideas more than about the person. Yeah, he was not one to attack people on a personal level. And in fact, he got on quite well with one or two of the more Marxist people.
Well, and he just comes across as such a logical thinker.
Yes.
That I can see why, as the, sort of zeitgeist becomes more emotionally charged, or, the sociology ends up rivaling the philosophy departments, right? That feels personal to him because it feels illogical, irrational.
Yes. Yeah, that's right. So he thinks, Lenin as a philosopher is just crazy, and to want to teach students a course on that when they could be doing something serious is just dreadful. Yeah. So he did get quite depressed by the splits in the political fights in the department and tried to go somewhere else, whereas Armstrong had a very combative temperament, was always prepared to come back and fight the political fight.
What about the influence of D.C. Williams and the notion of sort of like direct inference and building on some of these things?
Yes, he discovered at some stage the American philosopher Donald Carey Williams, especially his book called The Ground of Induction in 1947, and came to think that was the right solution to the problem of induction. That is why it's rational to conclude from the observed to the unobserved. And he wrote a book that developed that theory called The Rationality of Induction in 1986. That's Stove's book. And the basic idea of that is that it's a purely mathematical fact that the great majority, that if you have, say, a large population of black and white balls mixed, then in some proportion that you don't know, then the great majority of large samples that you take from that population approximately match the population in proportion of blacks and whites. And therefore, if you take a sample, most likely it has the same composition almost as the population. And therefore, it's a good bet that the proportion you observe is the same as the unobserved proportion in the whole population. So that is the Williams's justification of induction, and nobody had said anything like that beforehand. It was rather completely out of the blue.
What about the law of large numbers? How does
It
that?
is, that's right, it's a law of large numbers. There was, if you interpret it properly, there's you can see Jacob Bernoulli saying the same thing in 1700 when he developed the law of large numbers, but he didn't quite put it as a justification of inference from the observed to the unobserved. So yeah, you're quite right. Mathematically, it's the mathematical base of it is the law of large numbers. But to use it that way as a justification of induction took some more thinking.
Well, and this is another area that I feel like you can teach me a lot about, because there's this interesting connection between sort of the philosophy of science versus the practicality of doing science, right? And this idea of let's generate some ideas, hypothesis, thought experiments, whatever you want to call them, and play it out in a philosophical way. Whereas in the scientific world, your job is to build that experiment, deliver on it, have repeatable results, right? And in math, which is really your expertise, how does philosophy play a role in mathematics that's similar to sort of the philosophy of science playing a role in science?
Yeah, well, quite right. The philosophy of mathematics is considerably different to the philosophy of science. So science is uncertain inference, but hopefully quite good inference from observations. But mathematics is proof. It has a completely different its main methodology since the ancient Greeks is proof from axioms, meaning deductive proof from axioms. You start with axioms that you hopefully can see must be true, and you do step by step, as originally done in Euclid's Elements in 300 BC, and you reach conclusions that are as certain as the premises, even though there was not obvious. So certainly Pythagoras' theorem is certainly not obvious, but step by step you conclude from certain premises, and you say, oh, well, yeah, absolutely certain, it must be right. So the philosophy of mathematics has to explain that, and it should, in my view, explain also why those certain truths are not just in some abstract world of numbers and sets, but apply to the mathematical structure of the real world. So I wrote a book about that, an Aristotelian realist philosophy of mathematics, that says that the provable necessities of mathematics apply directly to the real world in cases of mathematical models. Or not even models, it just in things like the fact that 2 multiplied by 3, which you think of as 2 rows of 3 objects, 3, 3. If you divide that into columns, 2, 2, 2, they're the same 6 things. So 2 times 3 equals 3 times 2. That's a necessary truth, but it's true of actual tables and chairs. So the mathematical necessities that you can understandable mathematical necessities that you can see, you can understand why things must be as they are. Well, that's completely different to science. You can't understand why the constant of gravitation is what it is, because as far as we know, there's no reason why it is what it is. It just happens to be so. It's a contingency, but mathematics doesn't have contingencies like that. It has necessities, and that's why in the development of my own thinking, I felt that I was, because of studying pure mathematics, and then by studying logical probability, it was also about a necessity. So even though logical probability is about uncertainties, it's about necessary and certain relations between uncertainties. So I felt that from different perspectives, I was entering a realm of absolute necessities that you could understand that other people were not grasping the picture of.
This is going to be a far oversimplification, but in some ways there's an interesting dynamic about if you take the idea that math is deductive and science is inductive, right? And then you also have these other things where you're saying like the proof in math is a known truth, right? Whereas in science there is none, and this is a confusion that we all struggle with between certainty and uncertainty. Do you feel like there's been an oversimplification of the connection between math and science that's blurred these lines for the public to try to understand why they're actually opposites in some ways?
Yes. So people because mathematicians and scientists themselves are rather poor at philosophy and not interested in it, they haven't explained these matters. So of course everybody's confused. So they're confused about the fact that if science is in principle not quite certain, people like Kuhn are thinking, and Popper are telling you, oh well, it's not known at all. There's no good reason to think it. Whereas there is plenty of science that's it's correctly called certain. It's just not certain in the same sense of mathematics. So it's a certainty that influenza is caused by viruses and that the heart causes the blood to circulate. These are facts based on easily understood evidence, and they've been established for hundreds of years. So in that case, consensus in science is based on the evidence being extremely good, although as we know there are some other cases of consensus in science that maybe are not so based. So it's correct, it's fine to call science of those basic kinds certain, but nevertheless, philosophically, it's a different kind of certainty to proof in mathematics. So the difference is that in mathematics, understanding axioms and understanding proof from them, you can get a pure understanding of why things must be so. But it doesn't make sense to say that the blood must circulate. It's just how it is. And there's extremely good evidence for it, but it doesn't make sense to prove that it must be like that.
Is that partly because of the question why? I mean, I think science is trying to go to cause all the time, especially in medicine. So instead of saying the blood circulates because the heart's pumping, you attribute some causality to it, which is where you get in more trouble with certainty versus uncertainty. Whereas in math, we don't say 2 + 2 = 4. Why?
Because, no, right? That's right, yeah. Causality is normally not seen in mathematics. Explanation you see in mathematics, but causal is not quite right. Sometimes mathematics explains causality in the sense, if you ask why can't you fit a square peg in a round hole, well, the geometry explains why you can't, and it's kind of causal. You can't cause it to fit. So mathematics helps with causes, but nevertheless, in mathematics itself, it's not a causal discipline exactly.
Which is interesting when we look at sort of this postmodern era of science, and we see these statistical tests, which the layperson assumes is critical math, right? Finding truth, being used in some capacity to justify scientific outcomes, relationships, correlations that are not actually there, right? But it's the use of the mathematical tool that's justifying the scientific outcome or the cause, which is so wildly misinterpreted.
That's right, yes. The use of... there's something inherently workable about statistical testing, but there's so many ways to go wrong with it as well, and especially trying to get causes out of correlations. I think one of the still biggest difficulties in science is trying to get causes, causal inference to causes. So difficult, even if you've got the correlations correctly established.
And is that just a matter of like identifying the right variables, or sort of?
Well, we don't even know that. No.
Let's go back to Stove for a little bit and talk. There's some funny things that I wanted you to tell me a little bit more about, like when he applies for the job at New South Wales, I think.
That's right. Soon after graduating, he applied for a job in philosophy of science at University of New South Wales, then a new University of Technology, and due to an administrative error, he was placed second but offered the position. So fortunately, the university was expanding at that time, and they decided they could offer the position to both the candidates. So he was very lucky there.
So did they call him and they say, "I'm sorry, you should not have gotten that offer letter. It was meant for somebody else," or how did that?
I think that only came to light somehow years later.
Oh, funny.
Yeah.
That's interesting.
Yeah, so of course he wasn't maybe very deserving even of, because he had a position, because he hadn't done much. He should have, not long after that, about 1960, he should have become well known because because of the incident of Bertrand Russell's authorship of The Wisdom of the West. So Bertrand Russell wrote a book called The Wisdom of the West, which is a kind of popular history with pictures of Western philosophy, and he'd written an earlier successful history of philosophy. But in this case, well, he hadn't actually written it. He agreed for a sum of money to put his name on it, and it was actually written by another student of Anderson called Paul Fuchs. At one stage, Russell got a fit of conscience and was going to reveal this on TV, but the publisher persuaded him not to. But because Paul Fuchs was a student of Anderson, a lot of the content was very, very similar to Anderson's lectures on, for example, Plato. And in Australia, they noticed this, and Stove wrote a review of the book saying, well, look, it's extraordinary how much Anderson's lectures loom large in the history of Western philosophy. This can't really have been written by Russell.
That's such an astute reading.
Astute reading, yeah. That's right. But the whole thing was suppressed. Nothing happened further. The publisher managed to keep the matter quiet for 30 years.
Wow. That's a kind of remarkable.
Yeah,
he was right.
He was right, absolutely
Did David
right.
Stove find out that he was
Eventually,
validated
yes,
later?
30 years later.
Wow.
Somebody did the historical work, and Stove said, well, I told you so. There are many things on which David Stove could have said, I told you so. If you were still alive today and saw postmodernism and cancel culture, he would have said, I told you so.
Well, so let's talk a little bit about him getting cancelled, because I think he might have been one of the first people to be cancelled.
Yes, well,
and
I saw somebody write on the internet the other day, if Socrates were alive today, he'd be cancelled. Well, of course, Socrates was cancelled. So there is a long history of cancellation.
Okay, that's a good point.
At least we don't have to take the hemlock these days.
That's right.
Yeah. But yes, that's right. He did have difficulties in the 1980s when he said that Sydney University was appointing women to positions for political reasons when they weren't as deserving as the men candidates. And he got a lot of flack from that, and they did sort of threaten to sack him, and he kind of had enough and retired early. And his parting shot was an essay called A Farewell to Arts, meaning the arts faculty. And he said the Faculty of Arts at Sydney University is a disaster of the active kind, like a leaking nuclear reactor or an outbreak of foot and mouth disease in cattle. So, yeah, well, it was, once you retire, you can't be got at too much. But he was fortunate that he did enjoy his first years of retirement and was able to write what he wanted to write, though unfortunately he was a heavy smoker and after a while got esophageal cancer and became very depressed and eventually committed suicide.
And he escaped from a mental
Yes,
facility?
because of his degree of depression. He was confined to a psychogeriatric ward, but eventually tricked them into letting them out and went home and hanged himself. That was a very, very sad end. But considering the degree of depression, well, people were not inclined to blame him.
No, of course not. And there was something else that I read about how he had stopped smoking for a little bit, but found he couldn't write anymore.
That's right. He was trying to complete his last book, Darwinian Fairy Tales, which was an attack on the socio-biological interpretation of evolution. He stopped for 6 months, but he felt it kind of interfered with his concentration. He found he had to go back to smoking to be able to concentrate. So he did that and, well, obviously got worse. He did complete the book, but it wasn't published. I had to deal with that, the publication of it after his death.
So tell me a little bit about your friendship with him, because you're a student.
A student, yes. I was a student before and got along well with him, but didn't really expect that I'd continue to know him. I didn't expect really that I'd continue in philosophy either. I was expecting at that time to become a pure mathematician. And in the way of disciplinary people, he was thinking that I went overseas to do a PhD in algebra. And I guess he thought, well, I'm not, that guy was smart, but he's lost to philosophy. We probably won't hear much from him again. But I did get back to it, and gradually, mostly by writing and never by email. Now, I mean, he never got to email, but and sometimes I saw him, but a lot of our relationship was by letter. So I guess I was a little bit isolated in a mathematics department. But sometimes we saw each other. We discussed the ideas of probability and, well, lots of things. We had a large correspondence. I think it's not quite his largest correspondence. If I understand it rightly, his biggest correspondence was with your interviewee, Anton. So I'm sure Anton can tell you quite a lot about his relationship with David Stove.
And this is all in the archives that we're going to try and digitize.
That's right. The incoming letters are in the archives. That's right.
That's great. Why don't we talk a little bit about your work and how the trajectory that you followed, and you just had a book come out on ethics.
Yes.
So that's sort of an interesting evolution of your own.
That's right. So I've written about logical probability. For example, in my book called The Science of Conjecture, Evidence and Probability before Pascal, that's a book very much related to David Stove and his work on probability, but from a historical perspective. So it looked at the history of probability before the mathematicians got to it, so back in the Middle Ages. So the central part was about the medieval law of evidence, when they developed the concept of the kinds we now call proof beyond reasonable doubt. So not quantified at all, but grading the strength of evidence for hypotheses. They were extremely good at that. So it was history organised from the perspective of logical probability, because nearly all that happened back then was the probability of hypotheses rather than things to do with dice and coins that we think of probability as starting with now. And then I wrote a book called What Science Knows and How It Knows It, which was a kind of philosophy of science and scientific knowledge, again organised from the perspective of the rationality of the relation of evidence to conclusion. Then I did philosophy of mathematics, which is not to do with probability, except you can have probability of evidence for mathematical conjectures that you haven't proved yet, which is very interesting because it shows how much that kind of probability is a matter of just logic, because there isn't any observations or experiments or anything. It's just the pure relation of evidence to conclusion. My book, An Aristotelian Realist Philosophy of Mathematics, looks at the necessity of mathematics being implemented in physical reality. And then, so those two are about very much objectivist. They're very objectivist. They're very much about necessities, the necessity of the relation between evidence to conclusion, the necessity of the mathematical structure of reality and what you can understand about it. So then I moved on to ethics as well, and with the same conclusion, that it's completely objective and it's about necessities. So it's called The Worth of Persons, the Foundations of Ethics. So it says that the reason, for example, that murder is wrong is not a command of God or the custom of our tribe that helps us to get around and helps make society work. It's about something objective, namely that humans are ethically important, that it's a tragedy if a human dies in a way that a galaxy exploding is not a galaxy exploding, that's a lifeless galaxy, it's just a firework. But because humans, being what they are, rational and emotional and conscious and so on, there's something unique, ethically unique about them. And of necessity, it follows that they have rights, duties, and so on. And that the things that you normally talk about, ethics, like what to do, are kind of surface phenomena that follow of necessity from something more basic, that humans are really, really important entities.
And a sort of risk-reward, when there's a necessity that's high enough, ethics can change.
Yes, that's right. Ethics. So yeah,
I like it being tied to necessity in that way.
That's
because
right. So you could conclude a better understanding of human nature that some old tribal customs are actually not great. So we did conclude that about slavery, for example, that it's ethically unacceptable, no matter what the customs of some tribes are, just because of the equal worth of persons.